Installation planning overview. Decide on the boot methods, computer hardware requirements and compatibility. Update firmware or components. So when you install a new OS, you may need some new components. It's a really good idea. So new operating systems are supposed to take advantage of the CPU. They have special optimized routines to take advantage of a certain range of CPUs that they're designed for. You don't really want to install an OS on a chip that it's not designed for because it's made to work efficiently with that chip. So it may require you to do an upgrade. If you're going to install a new OS, you may have to upgrade your CPU, RAM, and motherboard. The operating system, a newer operating system, like say you have computer X and you have computer X operating system, or let's call it Y. So you have computer X and operating system Y, and you bought those together and they worked great for a year or two. And now they've come out with a Y+1 operating system, so the next generation of your operating system. Well, it is designed to work with your same chipset, but people don't like it when you apply it because what happens is it's made to do a lot more, and the programs that are made to run on it are more hefty, they're more demanding because they're made to run on the newer CPU. So the operating system isn't what slows down your computer, it's the other stuff that you apply, like Word and stuff like that. All those programs are like, I want more memory, I want more CPU. But the operating system itself is actually pretty efficient on the old chipsets. They're made, they get smarter, they take advantage of a lot of the techniques and things, and they come up with some efficiency routines and stuff like that. So it's generally not the OS that slows it down, it's the superfluous software that you're adding on there, which is not superfluous, you need it, right? It's stuff that you use every day. So, but generally it's the apps that will kill the computer, and that forces you to upgrade because it's just too slow. So it may require firmware updates or components. One example for a component might be RAM, you need more RAM. One example for a firmware might be that you're putting a much larger hard drive in the computer and the BIOS can no longer understand that, hey, that's a 500 gig hard drive, I can only understand 250, what is that, you know? So you may need to reflash the BIOS and then it'll work, right? So that's a firmware update. Is generally the only firmware you're gonna do in a computer is a BIOS update, the basic input-output system. And keep in mind when you're doing a BIOS update, you want to have it on a UPS because if it blinks during that time, you could nuke the whole thing. Sometimes you can recover them, but you're going to need to know what you're doing to do that. You might have to have some special tools as well. And then you're going to choose between an upgrade or a clean install. So do we upgrade it or do we install it? Generally, I used to rebuild computers about every 2 years because they get gnarly, messed up from people surfing and browsing all this stuff. So it's probably best if it's 3 months old, upgrade it. If it's any older than that, go ahead and do a clean install. You're going to get other benefits as well. Because if you have problems and you upgrade, you're dragging those problems along with you. And there can be some weirdness that happens in the older versions. The newer versions is pretty easy to do, seamless. But you still, if the computer's old, you might be better off reinstalling. And then you want to record and obtain information that you might need. So for example, the only thing you'd want to record and maintain back in the day was the COM addresses and stuff like that. So you have a COM1, COM2, the 3F8, 2F8, the interrupts 3, 5, 7, 11, whichever one you used, right? Whichever ones they supported. Different ones supported more options to give you more flexibility. So the more expensive computers would have let you, I know this presentation said that you can only use 3 or 5, right, for the COM ports, but that's not necessarily true because they used 3, 5, 7, and 11 for the better hardware. So installation planning continued. So we want to back up data and key files. So what is that? So we need to back up the data that we need and any key files, like if we have an encrypted OS or encrypted file system, we need to save those keys. We need to save our PGP keys for our email and stuff like that, right? But those should never be, this should not be the only place you have those anyway. Those need to be stored out in the cloud somewhere and protected or stored in a safe, you know, depends on what you're doing with the stuff, with the information, what kind of information you're looking at. So we want to remove and disable conflicts and verify existing settings. Again, if you get into the computer's admin systems and you see that you have an IRQ conflict, go ahead and fix that. Again, today's computers, we don't worry about that at all. It's just taken care of for us. You want to prepare the hard disk drive and the file system, so you have to format it properly if you're using OS X, or you're going to be storing OS X images on here for forensics use and it's a Windows system. You better have a hard drive in that computer or save a piece of it. You might want to partition it into 2 logical sections. So you have 1 hard drive We're going to use half of it for the Windows system, and we're going to use half of it for our forensics, right? But we're only going to be doing OS X forensics. So we're going to be looking at OS X file systems. Well, you better format it for an HFS Plus or an HFS X file system, right? So that's kind of what they're getting at here. Prepare the hard disk, drive, and file system. It doesn't mean just format it for Windows. You better think about what you're going to be using it for, right? Maybe this whole disk is for Windows and we add another hard drive for the other stuff, for the other images we're going to use. Because maybe we're going to do, you know, Solaris and Linux or something like that. And then you want to partition a hard drive disk with FDisk. So FDisk stands for fixed disk versus removable floppy disks. This is an old program, obviously. So it referred to fixed disks, which means the ones that did not come out of the computer. The floppy disks you could pull in and out of the computer, right? So that's where the term came from. And it would allow you to go in and set up the hard drive and create the primary partitions, the boot partitions, and all that kind of stuff.